Hello friends, welcome to Susan and John MathTube, and this is a video series where we are discussing old question papers and we are in question number 6. Okay, so you can see that they are asking mean and variance for the probability density function given by this, and you can see that it is defined piecewise, and my advice is you draw the real number system and you can mark infinity on the right side and you can mark minus infinity on the left side, and always keep in mind infinity and minus infinity are not included, so that's why I put dots. And now we can see the piece very clearly. Minus infinity to 0, the probability value or the function value is defined to be 0. And between 0 and 1, the function value simplified gives us x square minus x cube multiplied by 12. And after 1, the value is again 0. For discrete functions, the formula for mean is sigma pi xi, and the formula for variance or standard deviation squared is pi xi square minus mean squared. And in the case of continuous distribution, I told you a trick long back. Sigma will change into integral and pi will be the function value and xi will be the input value or the input variable. So the formula for mean denoted by mu is integral minus infinity to infinity. Look at this, xi will become x, pi will become f of x and dx. Now look at this, it is split according to the numbers marked in the real number system. That is minus infinity to 0 and plus 0 to 1 and plus 1 to infinity. And you can see the function value is 0 here, 0 multiplied by something will be 0, and here we have x multiplied by 12 into x square minus x cube dx and again 0 dx. And that will be equal to, this is gone because these are zeros. So 12 comes outside, integral 0 to 1. I'm going to take this x inside. I'm going to distribute this x cube minus x power 4. Those who do not know integration can take help of calculator. Your calculator is capable of doing integration provided they are not improper integrals, provided the limits are finite. Now, those who know integration can proceed with the formula. So, 12 into x to the power 3. That will be x to the power 3 plus 1 by 3 plus 1, x to the power 4 plus 1 by 4 plus 1, 0 to 1. You plug in the limits, you are going to get 3 by 5. So, remember, expectation or arithmetic mean or average, whatever you call, the value is 3 by 5. Now let's take a look at the question. What else do they want? Variance. Okay, so variance or standard deviation squared. So standard deviation squared or variance denoted by sigma square is given by integral. Look at this. Look at the formula in discrete. Sigma will become integral. Xi squared will become x square and pi will become f of x. Of course, limit is from minus infinity to infinity. minus mean squared. Mean we already found. I should have used mu. I'll write mean. Okay, mean squared. That is, the variance is given by, now the same process, minus infinity to 0, just like the previous one. Where is our number line? 0 to 1, 1 to plus minus 3 by 5 squared, because we already found the mean. And like I said before, this will be 0, this will be 0, and this is x squared, and 12 into x square minus x cube dx, and that is going to give me, this 12 goes outside, integral 0 to 1 x to the power 4 minus x to the power 5 dx minus 9 by 25, and that will be 12 x power 5 by 5 minus x power 6 by 6 within 0 to 1 minus, and that will be 12 into 1 by 30. You can just plug in the limits, it's routine work, and we get 1 by 25. Anyway, just a note, in case in your exam they ask standard deviation, don't forget to take square root and take the positive value. Okay, now let's go for the next question. See how important theory questions are. This is a third theory question we see in this question paper. One was very simple. They asked that mutually exclusive and independent. Then they asked the difference between hypergeometric and binomial. And now the third one is here, that is define standard error, explain its importance in inferential statistics, and write down the formula for standard error of sample mean and sample proportion. Okay, here we go. You have to prepare this properly using books or online sources. Anyway, the first answer I'll tell you, standard error is standard deviation. So what do you mean by standard error? It's a standard deviation of sampling distributions. Okay, let me tell you very clearly how statistics is used in real life. Okay, let's say we have a population. Population means you have to consider all the members, all the elements in a particular study. For example, if you are going to study about a certain community, you should include all the members in the community. If you are planning to study about a certain machine, all the machines that had been produced should be included. So the population normally will be very large, and collecting data from a population in many cases is impossible. So practically what we do is we divide the entire population into many parts and we take samples. We systematically, there are many methods for that. So we systematically take samples, and they're called cluster sampling, etc., etc. You can read about it. So there are many methods of sampling. So what we do is we study about the population with the help of samples. So to understand, there are two types of statistics. One is called descriptive statistics. Descriptive statistics means it describes a lot about the collected data, like a chart, a graph, everything. Descriptive statistics mainly deals about describing things. And the second one is inferential statistics. And in inferential statistics, what we do is we use samples, we analyze samples, we create patterns, not create, actually we find the patterns from the samples. For example, there are many famous distributions like the F distribution, chi-square distribution, T distribution. These are all found by analyzing samples. Anyway, we study the samples, we analyze the samples, and using the samples, we infer about, we come to a conclusion about. Inferring means to get to a conclusion. So we come to a conclusion about the population. I'll repeat once more. Normally in experiments, when we try to study about population, it becomes impossible because population size will be very large. Getting data from the entire population is something tedious and sometimes impossible. So normally in inferential statistics, what we do is we collect the samples, we analyze the samples, we study about the samples, and we create distributions, sampling distributions. And using all these stuff, we describe, we try to predict, we come to conclusions about the population. That is called inferential statistics. Okay, now the standard error means standard deviation of the sampling distributions. Anyway, so that explains standard error, but remember, whatever I told you right now is not enough. You have to read books or you have to depend on online sources, but you have to prepare a proper note. Don't write your own theory. Okay, now explains importance. Write down the formula for standard error of sample mean and sample proportion. Okay, standard error for sample mean is given by S by root n, and for proportion it is given by root under P 1 minus P by n. Yeah, that's more than enough, that's more practical. Whereas is the sample standard deviation. Now let's jump to the next question. This question is very important. It has been repeated many times. Okay, and it's a wonderful example. So what they do is they give a very small population. Let's say it's a shame to call this a population because normally in the experiments population will be so much. By the way, I forgot to explain. Suppose you are dealing with finite population, then standard error is given by, let's say you know the number of members in the population, and let's say that is capital N, and let's say your sample size is small n, then it's given by S by root n, root under n minus n by n minus 1. No. Okay, so a population consists of not live numbers, it's not alive, 5 numbers 4, 8, 12, 16 and 20. If a random sample of size 2 is drawn without replacement, find population mean, find population standard deviation, list all possible. Okay, normally they ask this kind of question, and sometimes they will even ask the sampling distribution. Anyway, I'll explain that along with this so that it will be beneficial for you. So look at this. The first thing to do is you write the population members 4, 8, 12, 16 and 20. Now second thing is you write the population size, and since it is finite, it makes sense. We can write population size capital N equal to 5. and then you can write required sample size. It will be mentioned in the question, small n is equal to 2. And now they are asking us list all possible samples. So I am going to write possible number of samples. I am going to use permutation and combination, and I am going to find possible number of samples. I want to know, before I write the samples, I want to know how many sample possibilities are there. And that will be nothing but NCN, that will be 5C2. I use a calculator and I got 10. Use a calculator and I got 10. Okay, now let's go for the first part. Take your calculator. I want to click and enter all these numbers. So we're going to get population mean. Mu is equal to, what's the formula for mu? Sigma x by capital N, and that will be 12. And population standard deviation, if you want, for a decoration's sake, you can put the formula over here, but you can use your calculator and find it. I got 5.66. Okay, now the main part, list possible samples. So the population is like 4, 8, 12, 16, 20. Now it will list in such a way that the elements, the sample members will not repeat. So the trick is do it systematically. And I am going to write and expect 10 samples, because we already found that there will be 10 samples without repetition, without replacement. So I am going to write possible samples, and then I will write sample mean. They have asked in the question. Now look at this. In this question, they have not asked sampling distribution, but now and then they are sampling distribution. Even if they are sampling distribution, the procedure is same. Okay, so possible samples. Look at this. I am going to write all the numbers that start with 4. 4, 8, 4, 12, 4, 16, 4, 20. Okay, that's it. Now I am going to write all the numbers that start with 8. If you want, you can erase this 4 so that there will be no confusion. So that gives me 8, 12, 8, 16, 8, 20. Now what I do is I'll erase this 8. I'll start with the 12. So 12, 16, 12, 20. 12, 16, 12, 20. And finally it's clear, 16, 20. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, now find the sample mean. 4 plus 8, 12. 12 divided by 2. I hope you remember how to find the arithmetic mean. Add, divide by number of items. So I'm getting 6, 16, 18. So that's it. That's the second part. Now they're asking, show that the mean of the sample mean is equal to the population mean. Now look at this. In some question papers, they will ask us to find the sampling distribution. And then they will ask what is the mean of the sampling distribution. In such questions, what we do is we will form the distribution and then find expectation of the distribution. But here it is given explicitly, find the mean of the sample mean. So we have all possible sample means. 6, 8, 10, 12, 10, 12, 14, 14, 16, 18. Now they are asking, find the mean of the sample mean. And that will be 6 plus 8 plus 10 plus 12 plus, you can use a calculator, and it came 120 out of 10, that is equal to 12, that is mu, that's a population mean. Now there is one more thing, they are asking standard error. Now look at this, there are two methods to get standard error. One is directly by using the formula. Now look at this, this is a finite set. We know capital N is equal to 5. We know the size of the sample is 2. So since you know these things, and we even calculated the population standard deviation, that is 5.66. Since we know all these three things, standard error is easily given by sigma by root n, root under n minus n by n minus 1, and that will be 5.66 divided by root under 2 into root under 3 by 4, and that gives me 3.46. okay, so that's it. So you can find standard error like this. Okay, anyway, even though it's not asked in the question, I want to discuss one more thing so that it will be beneficial for your exam. So suppose they ask sampling distribution of sample mean. What you do is, first of all you write, let capital X be the discrete random variable of possible sample means. That means I am taking capital X to be possible values of sample means. And like in all distributions, the second row will be its probability. I put different colors here. You can see that 6, 8, 16, 18 has not repeated. Anyway, I am going to write the numbers 6, 8, 10, 12, 14, 16, 18. Now what we do is we convert the whole story into probability. What is the probability of getting 6? You can see that we have listed all the possible samples. 6 comes only once. So in 10 we got 1 out of 10, 1 out of 10. Now look at this, 10 repeated 2 times, 12 repeats 2 times, 14 repeats 2 times. So 1 by 10, 1 by 10. Now you can find the sampling mean. And sampling mean, it's denoted by mu x bar. And it's given by usual sigma pi xi. That's what you call expectation formula. So 1 by 10 into 6 plus 1 by 10 into 8. Anyway, I made the calculation, I got 12. Now the second thing, standard error can be calculated directly. What was standard error? I had been telling you from the theory part itself. The standard deviation of the sampling distribution. Now look at this, this is the sampling distribution. So I am going to calculate root under variance, that is sigma pi xi squared minus mean squared. So that will be root under 1 by 10 into 6 squared plus 1 by 10 into 8 squared plus 2 by 10 into 10 squared plus minus 12 squared. Okay, I got the answer 3.46, which is the same answer as above. So remember, in case they are sampling distribution, you have to do this much. Anyway, let's stop this video here. I'll be back with the remaining question. So till then, my friends, bye.